All right, here we go. Concept 12, solving with log equations. I like logs. I hope you guys like logs too. I think they're a little bit fun. When we do these, you really just need to do little snails, and I love my little snails. For all of these things, we just really want to kind of look at what it would be snailed. So this would be x to the negative 2 is equal to 1/9. So again, it's this to the this equals this. Nice little snail action there. So remember, negative flips it. So we're already going to take care of the flipping action here. And then 3 squared would give me my 9. So if I said 3 to the negative 2, that would be 9 to the negative 1 power, and then that flips it to equal to 1/9. So 3 would be my answer. For this one here, I have 2 to the x is equal to 1. The only thing I can put in here that it would equal a 1 is a big old 0, and I will make it a happy face just because logs are cool. For this one here, this one you don't have to use logs for. You're just saying 121 to the x equals 11. Well, if I square root 121, it's equal to 11. I just need to remember that square rooting is the same thing as 1/2ing. So both of those are the two same things. All right, let's go ahead and look at these. These are all 3 different things. You need to make sure you know what to do with each. These so far are identical on both sides of the equation. If that much is good so far, all I need to make sure of is that those are both the same. So I set them equal to each other to make them both the same. So I move the x over there, I move the 9 over there, and I get 5 as my answer. So again, if these are both the same, you just need to make sure that everything else is too. This one here, I need to combine them. I need to put them together. So the plus means multiply. So we're going to do log base 6 of x times x plus 5. So I'm going to go ahead and do that. And if you only have one log, the only way to get over the log is to snail it. So we have 6 squared is equal to x squared plus 5x. And if I finish this up and move this over to the other side, so it's equal to happy 0, I get this. So when I factor this, this is what, x plus 9, x minus 4. So 4 is an answer when I set it equal to 0, and negative 9. Well, negative 9 is out. You're not allowed to have a negative in this little spot right here. So 4 would be my only answer. Last but not least, this guy right here, again, just one log. Same as what we did over here. Snail it. So we have 4 cubed equals 5x minus 1. And 4 cubed is 64. When I add the 1, I get 5x is equal to 65. And when I divide that, I get 13 as my answer. Sorry, you couldn't really see that. There you go. All right, we're on to the very last one here. And we're real nice. You're not going to be able to use a calculator for this, so we kind of leave the answers just like this, which is kind of nice because it helps you kind of think through the process a little bit that you're going to need to use logs. In order to get this alone, you need to undo everything. So we need to first move over the 5 and then move over the 2 because this is addition and this is multiplication. So first I'm going to move over the 5, which gives me 32. Then I'm going to move over the 2. I do that by division, which gives me 16, and I get to this problem here. Once I get there, I need to take the log of both sides. So remember, the x goes out in front. So we end up with x log of 6 equals log of 16. I just divide by log of 6 to get x all by itself, and oh happy days, that little dude there is sitting there waiting for you saying, yay, I have it right, yay. All right. That was fun. Concept 12, logs. Good times.